When you look up at the night sky, it feels still, silent, unchanging. The stars above seem to hold their places as if they have always been there and always will be. But the truth is very different. Out there, beyond the edge of our sight, galaxies are drifting, sliding, slowly closing the distance between them. These are not small things. They are islands of billions of stars moving on paths that will one day make them meet. And when they meet, the universe doesn't whisper. It transforms. Imagine two vast oceans of light stretching for hundreds of thousands of light years, drifting closer until their edges touch. The spiral arms twist, the stars are pulled, and new stars are born in the chaos. From far away, it looks like a slow, delicate dance, but it is a dance that will last billions of years. Tonight, as you settle into rest, let me take you into that story, the story of what happens when galaxies collide. The sky above us hides a secret of collisions. When we look up, the sky appears calm, a painting hung across the night. But every point of light has motion. Every galaxy is traveling, sometimes toward one another, sometimes apart. The stillness is only an illusion, like the ocean seen from a distance, calm on the surface, restless beneath. If your eyes could wait millions of years in a single moment, you would see shapes bending, stretching, and colliding. The sky you think is fixed is, in fact, alive. And the secret is this: our own galaxy is not safe from such encounters. The Milky Way, wide and spiraling, is already on a slow collision course. Its partner is Andromeda, a bright neighbor just 2 million light-years away. To us, that feels impossibly far, but in cosmic terms, it is practically next door. The space between is not empty. It is a bridge of dark matter and faint gas, a silent track along which these galaxies travel. They are coming closer, whether we notice or not. It may sound frightening, but remember, galaxies collide often. The universe is filled with the marks of past encounters. Peculiar galaxies with stretched arms and warped centers are the fossils of ancient collisions. Every telescope image of two spirals twisting into each other is a reminder, and this is not rare. It is the way the universe grows. The sky above you hides not just stars, but stories of endless collisions. This hidden truth adds depth to every glance upward. When you step outside and see Andromeda as a faint smudge in the night, you are not only looking at another galaxy, you are looking at our future. It is approaching, quietly, patiently. The sky is not a ceiling, but a moving stage, and galaxies are its dancers. Their collisions are written into the choreography of time, and it makes you wonder, what does a galaxy feel as it approaches another? Is there resistance, or is it simply gravity, unrelenting, guiding them forward? Questions like these remind us that the universe does not think the way we do. It simply is. Yet in that quiet inevitability, lies the greatest drama of all. The stage above us is alive with motion, even if we cannot see it tonight. Galaxies look peaceful, but they're always moving. A galaxy in a photograph seems frozen. You see the graceful spiral arms, the calm glowing center, the dust lanes tracing patterns, but the truth is, those arms are not still at all. They are rivers of stars, each moving in an orbit that takes millions of years to complete. It is like looking at a long exposure photograph of a city at night. Cars appear as smooth lines of light, but in reality, every car is rushing, every driver is making choices. Our galaxy is no different. The stars around us, including the Sun, orbit the galactic center at immense speeds. The Sun alone travels at about 828,000 kilometers per hour around the Milky Way's heart. Yet we don't feel it. To us, it is invisible motion. This is why galaxies appear peaceful. Their timescales are too grand for human senses. What feels like eternity to us is only a heartbeat to a galaxy. The same is true for Andromeda. It is not floating idly in the void. It is moving directly toward us at a speed of about 110 kilometers every second. Again, the number feels large, yet in the vast scale of cosmic distances, it is gentle, like two ships slowly closing the distance on a calm ocean. Every second brings us nearer to an inevitable meeting, even though it will take billions of years to unfold. This movement also explains why galaxies collide at all. Left alone, they might seem eternal in their spirals, but the pull of gravity between them ensures that paths cross. Gravity does not let go. Once two galaxies drift into each other's influence, the dance begins and there is no turning back. They spiral in closer and closer, like whirlpools merging in the same sea. So the piece you see in a galaxy is only the piece of distance, the piece of slow time. Behind it, movement never stops. The calmness is a mask. The universe is not frozen, and nothing in it ever rests. It is all motion all the time. And once you know that, the next time you look at the Milky Way, you might imagine it breathing, expanding, twisting, moving, and one day, colliding. A silent dance. Billions of years in the making. When galaxies collide, it does not happen in a flash. It is not like two cars crashing on a highway. Instead, it is a slow embrace, a process unfolding over billions of years. Imagine two dancers approaching from across a stage. They take steps so slowly you cannot see them moving, and yet, in time, they come together. The universe works with that kind of patience. The first step of this dance is approach. Andromeda and the Milky Way are already locked in each other's pull. For billions of years, they have been moving ever so slightly closer. We only know it because telescopes can measure the shift of light, showing Andromeda's approach. To our eyes, it is still just a faint smear in the sky, no larger than your thumb. But the truth is, the dance has already started. As galaxies draw near, they do not touch immediately. Their halos of dark matter and scattered stars brush against one another first. These halos are vast, reaching far beyond the visible spirals. Long before the bright disks collide, the invisible parts of each galaxy are already interacting, exchanging gravitational pulls. It is like two dancers extending their arms before their bodies meet. The dance itself can take several passes. The galaxies swing through each other, their shapes distorted, their stars flung outward, and then they circle back. This happens again and again until eventually the two merge completely. The process is delicate, almost like tides rising and falling, reshaping shores again and again until the coastline is new. Except here, the coastline is a galaxy, and the tide is the force of gravity itself. And the strangest thing? For the stars themselves, the dance is mostly silent. They pass by one another, rarely colliding directly because space is vast. What collides is the structure, the clouds of gas, the shapes themselves. It is a silent, graceful, but unstoppable dance, one that ends not in destruction, but in transformation. The partners do not fall. They become one. The future of our Milky Way is already written. Every galaxy holds a story, and ours is no exception. The Milky Way was born billions of years ago, and since then it has grown by swallowing smaller galaxies, absorbing them into its spiral arms. But its greatest chapter still lies ahead. The collision with Andromeda is not a guess. It is destiny. The motions have been measured, the math confirmed. It is written into the future of our stars. In about 4 billion years, the first approach will begin. Andromeda will swell larger in our sky, no longer a faint smudge, but a bright, glowing disk. Over millions of years it will grow, until its stars stretch across our heavens. Imagine future humans, or whatever descendants might exist, looking up to see two galaxies overlapping above. It will be a sky no artist could ever fully capture. The Sun itself may be moved. Our orbit around the Milky Way's center could be tugged, altered, even stretched outward. Some stars will be ejected into intergalactic space, flung far from their homes, yet Earth may survive untouched. The distances between stars are so immense that the chance of two stars colliding directly is very small. Our planet will simply sail on, carried into a new shape of galaxy. That new galaxy will be different. Instead of two spirals, the Milky Way and Andromeda will merge into a single, larger elliptical galaxy. The spiral arms will dissolve, leaving behind a rounded cloud of stars, glowing with new clusters. Astronomers already have a name for it: Milkomeda. A strange blend of our past and our future in a single new being. And perhaps the most profound thought of all, long after this happens, the collision will be forgotten by the stars themselves. New generations will rise, and the old spirals will be only a memory. Our galaxy's story will continue, but its identity will have changed forever. That is the way of the universe. Nothing remains as it was. Everything is moving toward what it will become. What happens when two giants finally meet? When galaxies finally overlap fully, the universe unveils one of its most spectacular sights. To an observer within, it may not feel like chaos, but to an eye from far away, it looks like two storms blending into one. The spiral arms are stretched into streams, stars pulled into great arcs of light. It is as though the galaxies are painting across the sky, their brushes dipped in starlight. The real collisions happen between gas clouds. These vast regions crash, compress, and spark furious waves of star birth. New stars light up like fireworks scattering across the scene. Entire clusters blaze into existence, young and hot, their lives beginning in the chaos of a galactic union. It is destruction, yes, but also creation, the universe's constant balance of endings and beginnings. Supermassive black holes at the centers of each galaxy begin their own dance. They orbit one another, spiraling closer until finally merging into a single, even greater black hole. This event sends ripples of gravitational waves across the cosmos, faint signals that might one day be felt by distant civilizations. A quiet tremor in the fabric of space itself. For billions of stars, life simply continues. They move into new orbits, some thrown out, others drawn in. Planets around those stars still circle, their skies forever changed, but their local lives unaffected. To those who live on such worlds, the heavens will tell a new story. Galaxies crossing, merging, glowing. But life itself will go on, largely untouched by the drama at the grand scale. And when the process is done, there will be no two giants anymore. Only one, a larger, stronger, rounder galaxy, glowing brighter than before. The Milky Way and Andromeda will no longer exist as we know them. Instead, a new cosmic giant will take their place. The question is not whether this will happen, but only how the story will look to those who are still here to see it unfold. A galaxy is not just stars, it's a living city of light. When we first hear the word galaxy, our minds jump to stars, endless shining points gathered together. But a galaxy is more than just stars. It is a living city with neighborhoods of young suns, old suns, rivers of gas, dark lanes of dust, and unseen structures of dark matter. Each part plays a role, like districts in a great city. And just like cities, galaxies are busy, full of quiet motion we rarely imagine. The stars you see form the bright skyline, but they are only a fraction of the whole. Around them lies the interstellar medium, clouds of hydrogen and helium that stretch across thousands of light years. These clouds are the raw material for future stars. When galaxies collide, These regions ignite with activity, birthing entire generations of suns. It is like a city suddenly booming with new construction after two civilizations merge. Hidden even deeper is dark matter, invisible to our eyes but crucial. Without it, galaxies could not even hold together. This unseen mass is like the unseen foundation of skyscrapers, keeping everything stable. During a collision, it's not just stars that shift, but these invisible structures too. The City of Light has invisible walls, and when they shake, the whole shape changes. What makes a galaxy alive is that it is never static. Stars are born, live, and die. Clouds are dispersed, new ones form. Black holes grow, clusters move. Over billions of years, a galaxy breathes in its own way, reshaping itself with time. That is why when two galaxies meet, it is not just a crash. It is two living cities blending into a larger one. And so the word galaxy is a simplification. What we are really talking about is an ecosystem on the grandest scale. An ocean of light, dust, and hidden gravity. Knowing this makes the story of collisions feel richer, because when they collide, it is not two frozen spirals touching, it is two entire living systems folding into each other, rewriting the night sky forever. The invisible glue dark matter holding shapes together. If you were to watch a galaxy spin without dark matter, it would fly apart. The stars move too fast, the orbits too wide. But something unseen binds them, something scientists call dark matter. It doesn't shine, it doesn't glow, but its presence is undeniable. It is the invisible glue holding every galaxy together. When galaxies collide, it is dark matter halos that meet first. Imagine two soap bubbles drifting toward one another. Long before their bright centers touch, the invisible edges merge and bend. That is how dark matter behaves. These halos overlap, slowing the galaxies, tugging them into spiraling paths toward each other. It's a silent handshake before the dance begins. We still do not know exactly what dark matter is. Is it made of particles we cannot yet detect? Is it a property of space itself? Each theory is like a key, and the lock has not been opened. But what we do know is this: without it, the story of colliding galaxies would look entirely different. Without dark matter, galaxies would not even exist long enough to collide. During a merger, dark matter shapes the final form. It dictates whether the new galaxy becomes a smooth elliptical or whether long tidal tails of stars are stretched into space. The visible fireworks, the bright bursts of new stars, are just the surface. The real sculptor is hidden beneath, in the dark. It is as though the stagehands of a play are invisible, but everything you see is arranged by them. And perhaps the most humbling thought: we are part of this unseen glue, our Milky Way's shape, the orbit of our sun, the security of our place in space. All of it is possible because of something we cannot touch, cannot see, and cannot fully understand. The galaxies collide because of it, and they survive because of it. Dark matter is the quiet architect of the universe. Why galaxies travel through space? Like ships in a vast ocean, galaxies are not fixed points. They drift like ships in a vast sea, carried by invisible currents of gravity. The universe is an ocean, and each galaxy sails upon it. Some move apart, pushed by cosmic expansion, while others are drawn together into inevitable encounters. Our Milky Way is one of those ships, and its course is set toward Andromeda. This ocean is not uniform. There are dense regions where galaxies cluster, like ports where ships gather, and there are lonely stretches where a single galaxy sails alone for billions of years. Collisions are most likely where galaxies live close together, in groups or clusters. Our local group, which holds the Milky Way, Andromeda, and dozens of smaller galaxies, is just such a gathering place. Think of the motion this way. Galaxies are like leaves floating on a pond, pulled toward one another when ripples overlap. But here, the pond itself is expanding. Space is stretching, pushing galaxies away from each other overall. Yet within this expansion, local gravity holds some together. That is why Andromeda approaches while most galaxies in the universe drift farther apart. It is a paradox. The ocean widens, but the ships can still meet. When two ships finally meet on water, the waves they create ripple outward. So too with galaxies. Their gravity stirs stars, dust, and dark matter, sending streams of material into the cosmic ocean. These tidal tails can stretch for hundreds of thousands of light years, glowing like faint trails of light marking the path of a journey long past. Every collision leaves a wake, and just as sailors once charted the stars to know where they were going, astronomers now chart galaxies to trace the great ocean of space. We are not lost at sea, we are passengers, carried by our galactic ship across the waves of the universe toward a meeting that will one day shape our very night sky. Collisions are not rare, they are cosmic, normal. When we hear collision, we imagine rarity, accidents, chance encounters, unusual disasters. But in the universe, collisions between galaxies are not rare at all. They are normal. Almost every galaxy has gone through one, or will in the future. Even the spirals we see as so elegant today may be survivors of multiple mergers. Collisions are not interruptions, they are part of the script. Astronomers see proof everywhere. Some galaxies are warped, their disks bent. Others have long tails of stars stretching out like ribbons. Still others show doubled cores where two centers are in the process of becoming one. These are snapshots of collisions in progress, each frozen in different stages of the dance. It is like walking through a city and seeing construction everywhere. Evidence that change is constant. Our Milky Way, too, is scarred by past collisions. The Sagittarius dwarf galaxy, a much smaller system, is being consumed by us even now, stretched into streams of stars that loop around the Milky Way. This is a small taste of what will happen on a grand scale when Andromeda arrives. We are not strangers to mergers. We are the product of them. Far from destroying galaxies, collisions often give them new life. The bursts of star formation triggered by colliding gas clouds can light up the universe with brilliance. In some cases, galaxies that might have faded grow brighter after a collision. In others, they become giants dominating their region of space. The universe is not careful with its creations, reshapes them constantly, and collisions are one of its favorite tools. So the next time you see a picture of two galaxies colliding, do not think of it as unusual. Think of it as ordinary, as natural, as storms rolling across an ocean. The universe is not static, it grows, it shifts, it collides. Collisions are not the exception, they are the rule. The Andromeda Galaxy, our future partner in collision. Among the billions of galaxies in the universe, one matters to us more than most: Andromeda. It is the largest in our local group, a spiral galaxy like our own, and it is on a direct course toward us. Right now, it lies about 2.5 million light-years away. That sounds enormous, yet in the language of the cosmos, it is simply a neighbor across the street. Andromeda is larger than the Milky Way, with perhaps 1 trillion stars compared to our few 100 billion. It has its own satellite galaxies, its own clusters, its own black hole at its heart. When it collides with us, it will not be a meeting of equals. It will be a meeting of giants, with Andromeda slightly more massive. Still, gravity cares little for pride. The two will merge, no matter their size, and become one greater whole. Already, astronomers can measure Andromeda's approach. Its light shifts slightly toward blue, evidence that it is moving closer. This blue shift is a rare thing. almost every other galaxy in the night sky is redshifted, moving away as the universe expands. Andromeda is the exception. It is swimming against the tide pulled toward us by mutual gravity. That is how we know our meeting is not chance. It is written in the movement of light itself. For now, Andromeda is a faint smear of light, visible only from dark skies. But imagine the future sky. As it draws nearer, it will become brighter, larger, until it stretches wide across the heavens. To the eyes of future beings on Earth, it will be the most astonishing sight ever seen. Another galaxy filling the night, so large you cannot look away. It will be beautiful, but it will also be the beginning of a transformation. And so when we speak of colliding galaxies, we are not speaking of distant theory, we are speaking of our own destiny. The Andromeda galaxy is our partner, waiting across the dark, moving closer every moment. The future of our Milky Way is not to remain as it is, but to merge with Andromeda and together become something entirely new. Why galaxies move toward each other silently. When we think of two great things moving closer, we imagine noise, the rumble of trains, the crash of waves. But galaxies approach in silence. There is no sound in the vacuum of space. Their meeting is written only in light, in gravity, in the bending of stars. From Earth, it feels like nothing at all is happening, yet every moment the distance shrinks. It is the quietest motion you will never hear. The silence can be deceptive. Andromeda is rushing toward us at more than 250,000 miles per hour. A speed so immense it could cross the Earth in less than a minute. Yet across millions of light years, that velocity feels gentle. This is why cosmic events don't feel dramatic. They are too large, too far, too slow for our senses to catch. Silence is the cloak of the cosmos. We often associate silence with peace, but in this case, silence hides transformation. Long before Andromeda arrives, its pull is already shaping us. Our galaxy stretches subtly, the halo tilts, and smaller galaxies are drawn into new orbits. You won't hear it, you won't see it. Yet the motion is constant. The universe works in whispers, not shouts. It is strange to imagine that something so huge can move without sound. But perhaps that is why it inspires awe. The stillness of night skies hides endless momentum. Galaxies carry entire histories across the void, civilizations rising, stars burning, and still they drift toward one another in absolute quiet. Their meeting is certain, yet their approach is like the soft closing of a door you didn't notice until it was shut. And one day, when they meet, the silence will continue. Stars will shift, black holes will merge, new suns will ignite. But through it all, the only witness is light. The universe does not need noise to tell its story. It moves silently, and that silence is part of its beauty. The speed of Andromeda, coming closer every second. Right now, Andromeda is not just sitting still in our sky. It is on the move, racing toward us with astonishing speed, about 110 kilometers every second. Imagine standing on Earth, watching an object cover the distance from New York to Los Angeles in less than half a minute. That is the pace at which our galactic neighbor approaches. Yet because of scale, we do not feel it. This speed has been measured carefully by astronomers. They track the shift of Andromeda's light. Instead of being stretched into red like most galaxies rushing away, Andromeda's light is compressed into blue. This blue shift is the signature of its motion toward us. Each photon is a tiny message whispering, "I am coming closer." And every second, that message grows stronger. The speed also reminds us of the power of gravity. Across millions of light years, the pull is still strong enough to drag galaxies together. The Milky Way and Andromeda are massive, each with their own gravitational well. The force between them is not gentle, it is a constant tug, pulling harder as the distance narrows. Speed is only the symptom, gravity is the cause. From our perspective, this approach is invisible to the naked eye. Tonight, Andromeda looks no closer than it did to our ancestors thousands of years ago. Yet telescopes reveal the truth. Even as civilizations rise and fall on Earth, Andromeda has been moving steadily nearer. Time on this scale reshapes the definition of soon. For the universe, soon can mean billions of years. So while we live in the present, Andromeda's journey continues. Every heartbeat, every passing moment brings us closer to the day when the two galaxies will meet. The speed may be unnoticeable now, but it is relentless. And in cosmic stories, relentlessness always wins. A timeline. 4 billion years until the encounter. The collision between the Milky Way and Andromeda sounds like something that could happen tomorrow, but in truth, it lies far in our future. Astronomers estimate the first close encounter will happen in about 4 billion years. To human minds, this number is almost meaningless, but to the universe it is only another page turning. Time flows differently on the cosmic clock. 4 billion years is not as far as it seems when we remember Earth's history. About that long ago, our planet was just beginning to form continents, oceans, and early life. Since then, it has carried entire ages of creatures, from trilobites to dinosaurs to us. Imagine another 4 billion years ahead. What stories might Earth hold then? What beings might look up at the sky and watch Andromeda fill the heavens? The timeline also shows us how slow collisions are. Even once the galaxies meet, the full merger will not happen overnight. It may take another 2 billion years after first contact before the new galaxy settles into its final form. That means this is not an event, but an era, a chapter of cosmic time written across billions of years, unfolding slowly, patiently, inevitably. Our descendants may never exist in their current form when the meeting begins. Civilizations may rise and fall many times before Andromeda dominates our sky. Yet the knowledge that it will happen connects us to the future. We live in a universe where destinies stretch longer than lifetimes, longer than species, longer than planets. The story of galaxies is always bigger than us, and still, even with that scale, there is comfort. The timeline is so long that we are safe. The Earth will not feel a shock. Our sun will keep shining. We can look upward, knowing that the greatest collision in our galaxy's future is not a threat, but a distant, unfolding promise of change. Why you will never feel the collision yourself. The word collision suggests violence. We imagine impact, heat, destruction. But when galaxies collide, it is not like two stones striking. It is more like two clouds drifting through each other. The distances between stars are so vast that almost none of them will touch. You here on Earth would never feel the moment of collision. Life would simply continue while the sky changed above you. To put it in perspective, if the sun were the size of a coin, the nearest star would be another coin placed thousands of kilometers away. That is the spacing of stars in a galaxy. So when galaxies merge, the stars glide past one another. Their gravitational paths change, yes, but physical crashes are rare. It is almost like two swarms of fireflies crossing paths without the insects ever touching. The real drama happens in the invisible parts. Gas clouds collide, compress, and spark new stars. Black holes spiral closer, their gravity pulling everything around them. But for a planet orbiting a star, there is no catastrophic impact. The planet simply goes where its star goes. Earth will follow the sun will follow its new orbit, and life may barely notice the larger event. That does not mean the view will be ordinary. To those who live then, the sky will change beyond recognition. Andromeda will rise, stretch, and eventually cover much of the horizon. It will be a spectacle, not a disaster. Entire civilizations may mark their calendars not by seasons or years, but by the stages of Andromeda's arrival. For them, the collision will be a story written in the sky. So while the word collision suggests danger, the truth is gentler. You will not feel the crash. You will only see the beauty. The universe collides not to destroy, but to create, to transform, and to remind us how much larger its time and space are than our fears. How vast distances make stars mostly miss each other. It feels strange, doesn't it? Billions of stars moving into one another, and yet almost none colliding. That is the magic of distance. Stars may look close when we see them in the night sky, but in reality they are separated by light years. That distance is so immense that even during a galaxy collision, the odds of two stars colliding directly are near zero. Imagine two swarms of birds flying into each other. From far away, it looks like chaos, but the birds weave, bend, and pass by. Rarely do they strike. Stars do the same, guided not by eyesight, but by gravity. They glide past, orbiting new centers, reshaping into new formations. The collision is real, but the impact is spread across space, not concentrated in a crash. This also means that our Sun, and Earth with it, has little to fear. We may be shifted into a new orbit, pulled outward or inward depending on the flow of gravity, but we are unlikely to collide with another star. The spaces between are simply too vast. That is why the universe can allow billions of galaxies to merge without becoming nothing but wreckage. The scale protects us. And yet, these near misses still leave marks. As stars pass close, their gravitational pulls can disrupt planetary systems. Some planets may be cast adrift, wandering through interstellar space without a star. Others may be dragged into new suns, given new homes. These are the smaller, quieter dramas within the great dance of galaxies. So the truth is both simple and profound. Collisions of galaxies are spectacular, yet stars within them remain safe because of distance. It is a reminder that space is not crowded, it is vast beyond imagination. What looks like closeness from Earth is really separation on a scale so immense that even entire galaxies can merge without stars ever touching. What happens when galaxies begin to overlap? When two galaxies draw close enough, their halos touch first, those invisible spheres of dark matter and faint stars. Then slowly, the bright disks overlap. From far away, it looks like two spirals pressing into each other, their edges blurring. The overlap is not sudden, it's stretched over millions of years. To our eyes, it would look like a slow sunrise, each arc of stars mingling with another until you can no longer tell where one galaxy ends and the other begins. This overlapping is where the real drama begins. The neat, spiral arms we know become stretched, twisted, and tangled. Like two dancers whose costumes trail behind them, the galaxies leave streams of stars spilling out into space. These are called tidal tails, and they can stretch for hundreds of thousands of light years. To astronomers, they are the signatures of merging galaxies, long, faint ribbons of light marking the blending of two giants. But inside the overlap, the story is more chaotic. Gas clouds crash together, heating and collapsing into bursts of new stars. Where once the galaxy might have been calm, suddenly it becomes alive with clusters of blue, hot suns burning bright and fast. The overlap zone becomes a cosmic nursery. Creation happens in the same space as destruction. It's easy to imagine galaxies as enemies smashing into one another, but overlapping is more like a blending. Their motions are guided not by anger, but by gravity's patient hand. Each spiral bends, stretches, and flows until they are inseparable. The overlap is not the end of either galaxy. It is the beginning of something neither could become alone. And perhaps the most beautiful thought, from a planet inside, the night sky would slowly transform. Stars once familiar would shift, constellations would stretch, and strange new rivers of light would appear overhead. The overlap is not just an astronomical event. It is a rewriting of the heavens themselves. Tides in space, stars pulled into new shapes. We know tides on Earth. The pull of the moon lifting the oceans, reshaping coastlines every day. Now imagine that same idea on a galactic scale. When galaxies approach, their gravity pulls at each other, creating tides in space. But instead of water, it is stars and gas being tugged, stretched, and drawn into delicate arcs. Entire constellations of suns are pulled, like waves rising toward the shore. These tidal forces are powerful, yet subtle. Stars are not ripped apart. Instead, their orbits are altered. Some are flung far into the outskirts, becoming lonely wanderers. Others are drawn inward, forming dense knots around the galactic centers. The galaxies themselves begin to elongate, no longer perfect spirals, but distorted, graceful shapes, as if painted with a trembling brush. One of the most spectacular results of these tides are tidal tails. They are streams of stars pulled out into long, glowing arms that extend far beyond the main bodies of the galaxies. They look like bridges in the sky, delicate threads connecting two vast islands of light. Each tail is a trail of history, showing where stars once belonged before gravity sent them drifting into new paths. Sometimes, stars pulled into these tails can gather together, forming entirely new dwarf galaxies. In a sense, collisions give birth to children, smaller galaxies born from the scraps of larger ones. It is another reminder that in the universe, endings are always paired with beginnings. What looks like tearing apart is also a quiet act of creation. And if we were to watch from Earth, tides in space would appear as the slow reshaping of the Milky Way's form. Spiral arms would stretch, twist, and fold. To us, the sky would look as though the galaxy itself were bending under invisible winds. These are the tides of space, patient but unstoppable. The strange bridges of stars between colliding galaxies. As two galaxies near, a remarkable phenomenon often appears: bridges of stars connecting them. These bridges are formed by gravity's pull, stretching streams of stars and gas across the gap. They glow faintly, like threads of light sewn between two cosmic fabrics. To astronomers, they are both haunting and beautiful, proof of galaxies reaching out to each other. The bridges are not solid highways, of course. They are made of stars scattered across hundreds of thousands of light years. To anyone living inside them, they would not appear as a bridge at all, but as a strange scattering of stars in the sky. Yet from far away, the shape is clear. The galaxies are linked, their fates entwined, their paths no longer separate. These bridges can carry more than stars. Gas and dust flow along them, fueling bursts of star formation where the material gathers. In some cases, black holes or star clusters are exchanged between galaxies, carried like passengers across the bridge. It is as if two great kingdoms build a road between them, and along that road, treasures are traded. The antennae galaxies, a famous example, show these bridges clearly. In their photograph, long arcs of stars sweep outward, connecting the two spirals in a delicate embrace. These arcs are not just ornaments. They are the evidence of a bond forming, the visible lines of gravity sculpting the future. For the Milky Way and Andromeda, bridges of stars may one day arch across our skies. Imagine stepping outside and seeing not just our own galaxy, but streams of stars leading directly into another, a sight so vast and strange that it would make the horizon itself feel small. That is the power of stellar bridges. They show us that even in collisions, there is connection. Cosmic fireworks, new stars bursting into life. One of the most dramatic results of galaxy collisions is the sudden birth of new stars. When gas clouds inside galaxies collide, they compress, and in that compression, gravity takes hold, pulling atoms together until nuclear fire ignites. Entire clusters of stars can burst into life in waves, lighting up the galaxy like fireworks in the night. These are called starbursts, and they are among the brightest events in the universe. Starbursts often happen in the overlapping regions where gas is most disturbed. There, chaos becomes creation. Blue-white stars appear, hot and massive, living short but brilliant lives. Some will explode as supernovae within only a few million years, scattering heavier elements into space. Others will form long-lasting clusters, glowing for billions of years after the collision has ended. The fireworks may fade, but the stars they create remain as lasting monuments. For astronomers, these bursts are like time capsules. They can study galaxies mid-collision and see regions glowing with infrared light, a sign of dust heated by newborn stars. To us, these galaxies look alive, almost burning with energy. The collision turns them into beacons, more luminous than they were before. It is proof that collisions far from ending galaxies can breathe new life into them. On Earth, if beings exist to watch, the starbursts will change our night sky. New clusters may glow with colors unseen before, scattered across the heavens. Constellations could shift not just by motion, but by sudden additions of light. For those who look up, it will feel as if the universe itself has decorated the sky with new jewels. And perhaps the most striking truth is this: without collisions, many stars would never exist. Even our sun may have been born in a galaxy long ago, shaped by encounters. Fireworks of light are not accidents. They are part of the cycle. The universe collides so that it can shine again. Dust clouds, colliding to create brilliant birthplaces. While stars rarely collide, clouds of gas and dust almost always do. These clouds are the soft, hidden material inside galaxies, and when they meet, they crumple and collapse. The pressure inside them rises, and suddenly they become wombs of light. It is in these dusty collisions that the brightest star-forming regions appear. Brilliant birthplaces glowing in pink and red, visible even from millions of light-years away. Dust may seem insignificant, but it is the seed of creation. Every star, every planet, every person is made of matter that once drifted as cosmic dust. During a galaxy collision, these clouds are forced together. Gravity takes over, squeezing them into dense knots that ignite with fusion. From dust, suns are born. From suns, worlds are built. And from worlds, life may, one day, arise. These birthplaces often appear as glowing nebulae, vast, colorful clouds filled with new stars still wrapped in their cocoons. In photographs of colliding galaxies, you can spot them shining like gems, scattered across the chaos. They are not scars, they are signatures of renewal, proving that even in disorder, beauty emerges. The dust also spreads. Supernovae from the newly born massive stars will enrich the galaxy with heavier elements: carbon, oxygen, iron. These materials drift into new clouds, ready to form the next generation of suns and planets. Collisions do not just create stars, they create the ingredients of life itself, distributed more widely after each encounter. So when you think of galaxies colliding, do not imagine only destruction. Picture the dust, glowing with energy, collapsing into brilliance, scattering seeds across space. The greatest birthplaces in the cosmos are born from these meetings. Collisions are not just endings, they are fertile grounds for beginnings. Why stars rarely smash head-on? When galaxies collide, you might expect stars to crash into one another like cars on a crowded street. But the truth is far stranger and gentler. Stars are separated by such immense distances that even in the chaos of two galaxies merging, they almost never touch. Space is mostly emptiness, and it is that emptiness that protects the stars. They pass by each other like ships on a wide, open sea. Imagine shrinking the sun to the size of a grain of sand. On that same scale, the nearest star would be another grain of sand placed dozens of kilometers away. That's how much space lies between stars in a galaxy. So when galaxies collide, it is like throwing two handfuls of sand into the air. Most grains miss, carried by the breeze, following new paths but rarely hitting. Instead of smashing, stars are rerouted. Their orbits are bent, tugged, and sometimes flung out of the galaxy entirely. Others are drawn inward, circling closer to the galactic heart. This is the real drama of a collision, not destruction, but redirection. Gravity is the invisible hand, writing new stories for each star without shattering them. That does not mean there is no risk at all. Some stars may pass close enough to disrupt each other's planetary systems. Planets can be tugged away, cast into the void, or exchanged between stars like wandering gifts. These are the quiet casualties of collisions, not explosions, but lost homes. Yet even these events are rare compared to the vast ocean of emptiness between suns. So the lesson of galaxy collisions is this: stars are safe because the universe is vast. Collisions reshape galaxies, but they almost never destroy stars. The real action lies elsewhere, in the clouds of gas, in the dark hearts of galaxies, and in the birth of new stars born from chaos. Gas clouds are the real crash victims. While stars glide past, gas clouds cannot. These great drifting masses of hydrogen and dust are wide, sprawling, and fragile. When galaxies collide, their gas clouds slam into one another. The impact is not fiery in the way we imagine, but it is transformative. The clouds compress, heat, and collapse, triggering waves of new star formation. In these collisions, the true fireworks of galactic merging are ignited. Think of gas clouds as the lungs of a galaxy. They breathe out stars, then inhale the scattered remains of old ones. But during a collision, those lungs are squeezed. Suddenly, stars are born in numbers far beyond normal. Bursts of light sweep through the galaxies as young suns flare into existence. These regions glow brightly, glowing like embers carried by the wind across the dark. The clouds also create turbulence. Shock waves ripple through them, causing fragments to collapse in unpredictable ways. Some form massive clusters of stars that shine fiercely but briefly. Others form gentle streams of smaller stars that last for billions of years. The diversity of results comes from the chaos of cloud against cloud, dust against dust. In this way, galaxies are transformed not just by their shapes, but by their new generations of stars. Old galaxies may look tired with fading light, but a collision injects them with new life. The newborn stars are like sparks in the ashes, sudden, brilliant, and unstoppable. Collisions are a way for the universe to rejuvenate itself. So while stars themselves rarely collide, their nurseries do. And it is in those collisions that galaxies are truly reborn. The victims of merging galaxies are not stars, they are clouds. Yet from their destruction comes beauty that lights the cosmos for ages to come. A storm of supernovae lighting up the darkness. When starbursts ignite during a collision, the stage is set for an even more dramatic act: supernovae. These massive newborn stars burn hot and fast. Within a few million years, many will collapse and explode, scattering their elements into the surrounding space. In a colliding galaxy, Supernovae can erupt by the thousands, turning the dark into a storm of light. These explosions are not just bright, they are essential. Every supernova releases heavy elements, carbon, oxygen, iron, the building blocks of planets and life. Without them, the universe would remain simple, filled only with hydrogen and helium. Collisions accelerate this enrichment, creating fertile ground for new worlds. Chaos becomes creativity at the grandest scale. The light from these supernovae can outshine entire galaxies for a brief time. Imagine looking up and seeing a star flare so brightly it rivals the glow of the moon. In colliding galaxies, such sights would not be rare. The heavens would shimmer with sudden brilliance, each burst a reminder that death and creation are one in the cosmic cycle. But supernovae also send shockwaves into their surroundings. They stir the gas, compressing new regions, sparking yet another round of starbirth. The process feeds itself. Stars ignite, explode, scatter material, and from that material, more stars are born. It is a storm that sustains itself, a loop of destruction feeding creation. So when galaxies merge, they do not simply mix their stars, they trigger cascades of brilliance, storms of light, and showers of elements. Each supernova is a punctuation mark in the story of a galaxy, a reminder that even in endings, the seeds of new beginnings are always scattered. Black holes in the heart of galaxies, meeting each other. At the center of nearly every galaxy lies a supermassive black hole. These monsters weigh millions, even billions, of times more than the Sun. Normally, they sit quietly, hidden by dust and gas, feeding slowly. But when galaxies collide, their black holes are drawn toward each other. The centers of gravity themselves begin a dance that will end in one of the most powerful unions the universe can create. As the galaxies merge, their cores spiral closer. Around them, gas and stars are stirred violently, feeding the black holes with new material. This feeding makes them blaze as quasars, shining brighter than entire galaxies. The once invisible giants become lanterns of cosmic light, announcing their presence to the universe. For a time, the colliding galaxies glow with their fury. The black holes themselves move slowly. Over millions of years, they orbit one another, tightening their spiral. It is not a quick dance, but a patient circling, each loop bringing them closer. Gravity waves ripple outward as they move, faint vibrations across the fabric of space. We cannot hear them, but instruments may someday feel their song. Finally, when they meet, they merge into one larger black hole. In that moment, the most extreme event of the collision occurs: the blending of two centers of gravity into one. The result is a black hole greater than either parent, ready to anchor the new galaxy that has been born. It is as though the universe takes two hearts and fuses them into one. And so the story of colliding galaxies is also the story of colliding black holes. Invisible to us most of the time, they are the true rulers of galaxies. When they meet, it is not just a merger of stars, but a union of gravity itself. When two supermassive black holes dance together, before the final merger, there is a long courtship. Two supermassive black holes orbit each other, locked in a gravitational embrace. Astronomers call this a binary black hole, and it is one of the strangest dances in the universe. They spin closer, slower, like titans circling a ring, each loop carrying them toward a fate they cannot avoid. This dance releases energy in the form of gravitational waves. These waves ripple outward, bending space itself. If you could somehow see them, they would look like gentle vibrations running across the cosmos. Here on Earth, sensitive detectors like LIGO have already caught smaller versions of these waves from merging black holes. One day, we may catch the deep, resonant signal of galaxies colliding. For the stars nearby, this dance is perilous. Some are flung outward, cast into new orbits by the immense tug-of-war. Others may be captured, spiraling inward and swallowed whole. The black holes feed on the chaos, growing larger as they prepare for their final union. It is a feeding dance, a circling feast, and when the dance ends, the merger is sudden. Two become one, releasing an enormous burst of energy in gravitational waves. The universe itself quivers in response, though silently. To distant observers, the glow of the surrounding gas may flare, marking the end of the dance. A new, larger black hole now sits at the center, ready to govern the new galaxy that has formed. It is a reminder that at the heart of every galaxy is mystery. Black holes are not just destroyers, they are the anchors of creation, shaping galaxies, guiding stars, and in moments like these, dancing with one another before becoming something even greater. Spiral galaxies torn into elliptical shapes. Spiral galaxies are elegant, arms coiling outward, dust lanes curling like brushstrokes, but collisions rarely let them keep that grace. When two spirals merge, their delicate patterns are disturbed. The arms are stretched, shredded, and slowly lost. Over billions of years, the spirals fade into a new form, an elliptical galaxy, smooth, rounded, without the clear structure of arms, but with a calm glow of countless stars. This change happens because the orbits of stars are scrambled. Spirals are orderly, with stars moving in a common plane. Collisions throw that order away. Stars scatter into random orbits, filling space in every direction. From this chaos, a new equilibrium forms, not spiral, but spherical. The galaxy becomes less like a spinning disk and more like a glowing cloud. Ellipticals are often older looking. They are redder, with fewer young stars. This is because their gas has been used up or blown away in the frenzy of collisions. Without gas, fewer new stars form, leaving behind only the older ones. It is as if the galaxy has aged suddenly, losing the youthful blue light of starbursts and keeping only the red embers of its elders. And yet, ellipticals are not lifeless. They shine with billions of stars, many packed more densely than in spirals. To anyone living inside, the night sky would be brighter, filled with more stars than we see in the Milky Way today. The transformation takes beauty away in one sense, but gives it back in another. In density, in sheer number, in glowing abundance. So when two spirals collide, we are witnessing not an ending, but a metamorphosis. The butterfly shape of arms dissolves, but in its place rises a galaxy of new character, stable and calm after the storm. Ellipticals are the memory of spirals, worn smooth by time and encounters. Arms of the Milky Way, becoming threads of stars. The Milky Way's arms, Orion, Sagittarius, Perseus, are like the highways of our galactic home. They hold our sun, our Earth, and countless clusters of stars. But when Andromeda arrives, these arms will not stay intact. They will be pulled, stretched, and torn into long threads of stars. From above, the Milky Way will look less like a spiral and more like a tangle unraveling in the wind. These threads, or tidal streams, are not random. They trace the paths stars are pulled into by gravity. Some will stretch far into intergalactic space, faint rivers of light connecting our galaxy to Andromeda. Others will wrap around, forming loops and arcs that may one day merge back into the new galactic center. They are both scars and signatures, evidence of a galaxy reshaped. For us, this transformation will change the sky. The familiar spiral structure will vanish, replaced by scattered ribbons of stars overhead. New clusters will appear where the streams thicken, glowing like jewels on a necklace. To future astronomers, these threads will be roadmaps of the collision, tracing exactly how the galaxies pass through one another. Such streams already exist today around the Milky Way. We see the remnants of smaller galaxies we've absorbed, their stars now looping around us in delicate arcs. These are small previews of the much larger unraveling to come. When Andromeda collides, our galaxy's very arms will become streams, not just of stars, but of history. The Milky Way's spiral arms gave us a home, a place to trace constellations, and a framework for our cosmic identity. But they are temporary. In time, they will dissolve into threads, and from those threads, a new galaxy will weave itself. Andromeda's core, stirring our night sky into chaos. At the heart of Andromeda lies its glowing core, denser and brighter than our own. As it approaches, this core will rise in our sky, no longer a faint blur, but a dominating light. Imagine a night where not just stars, but an entire galaxy's center fills your view. The effect would be overwhelming, a slow-motion spectacle of cosmic closeness. When cores of galaxies interact, they stir everything around them. Their gravity pulls on stars, gas, and even black holes, distorting orbits and dragging material inward. The Milky Way's center and Andromeda's center will orbit one another for millions of years, spiraling closer like two whirlpools pulling the ocean around them. The night sky will show their progress, first side by side, then overlapping, then merged. This stirring will create chaos. Stars near the cores may be thrown outward, forming new clusters or escaping entirely. Gas will rush inward, fueling black holes and igniting quasars. The central regions of both galaxies will glow fiercely, brighter than ever before. To eyes on Earth, it may look like our sky has gained a second sun, not burning close, but glowing vast across the heavens. Yet within that chaos, patterns emerge. The two cores do not simply collide and vanish. They circle, merge, and stabilize. The eventual result is a single, larger core, the heart of a new galaxy. It will be more massive, more powerful, and more stable than either alone. The chaos is temporary. The calm afterward will last for billions of years. And so Andromeda's core is not just a light in the distance. It is the spark that will stir our future night sky into a theater of change. The calm heavens we know will be replaced by a vision of closeness, of merging, of transformation. And we, if we are still here, will be its audience. Star systems being tossed into new orbits. For stars caught in a collision, the drama lies in motion. Orbits that were once steady are disrupted. Some stars are pulled closer to the galactic center, while others are hurled outward, flung into long arcs that may never return. It is like marbles scattered on a floor. Some gather near the middle, others roll to the edges, some escape the room entirely. The Sun itself may experience this. Today, it orbits calmly around the Milky Way's center, but during the collision, that orbit could shift dramatically. We might be drawn outward into the galaxy's new outskirts or inward toward its denser regions. For Earth, it would not feel like a crash. The sky would change, the constellations would rearrange, but daily life could continue, unaware of the slow cosmic migration. Some stars will not be so lucky. Pulled too strongly by gravity, they may be ejected from the galaxy altogether, becoming rogue stars drifting in intergalactic space. Imagine a lonely sun carrying its planets into the darkness, away from any galactic home. These wanderers are rare, but they exist, children of collisions, carrying light into the void. Others may be captured into new clusters. Stars that were once strangers may find themselves orbiting together, bound by new gravitational ties. Collisions shuffle the deck of galaxies, creating new families of stars where old ones are broken apart. The randomness is part of the beauty. From disorder, new patterns emerge. So while galaxies collide on the grandest scale, the story is personal for each star. Some are flung, some are captured, some remain steady. Every system is touched in some way, each one rewriting its path in the aftermath of the Great Meeting. Why some stars will be flung out into intergalactic space. Perhaps the most dramatic fate of all is reserved for those stars caught in the strongest tugs of gravity. During collisions, some stars are slingshotted out with such speed that they escape not just their home galaxy, but the merged galaxy that follows. These stars are cast into intergalactic space, drifting alone with no galaxy to belong to. These are called runaway stars or intergalactic stars. They carry their planets, if they have any, into an eternal journey through the dark. Without a galaxy, the night sky above such a planet would be haunting. Only distant galaxies faint and far away, with no bright band like the Milky Way to stretch across the heavens. A lonely light in a sea of emptiness. The reason stars are flung away lies in gravity's tug of war. When two galaxies pass, the combined forces can accelerate stars to escape velocity. It is the same principle that spacecraft use when slingshotting around planets, but on a cosmic scale. The result is a scattering of suns spread into the void, invisible unless seen from afar. Astronomers have found evidence of such stars. Some appear to be moving so fast they cannot be bound to the Milky Way. These may be remnants of past collisions, survivors of encounters long forgotten. They are living proof that galaxies leave behind wanderers, lights untethered, carrying silent stories of the dance that expelled them. And so, while most stars will remain, some will be forever lost. They will travel the intergalactic night alone, carrying their light as a message. Collisions reshape not just galaxies, but individual stars. Some become part of something greater. Others are set free into endless solitude. New nebulae spark from compressed clouds. When galaxies collide, clouds of gas are pressed together, creating vast glowing regions called nebulae. These nebulae shine with the light of newborn stars hidden inside them. To telescopes, they appear as colorful clouds, pink, red, sometimes even green and blue, stretching across the overlap zones. They are the wounds of the collision, but they are also the nurseries where new life begins. Out of compression comes creation. Nebulae are fragile, shaped by every ripple of pressure. Some form quickly, glowing for only a few million years before their stars disperse them. Others last longer, stretching like banners across the galaxies. During collisions, entire constellations of nebulae may appear at once, dotting the galactic disks with glowing patches. To astronomers, they are signs of an ongoing merger, like sparks leaping from a fire. Inside each nebula, stars are being born. The gas collapses into dense knots and gravity ignites fusion. These newborn stars often form in clusters, bright and hot, destined to shine fiercely but briefly. Their radiation lights the gas around them, making the nebula glow even more. Without the chaos of collisions, many of these stars would never exist. Collisions give the nebulae the push they need. Some nebulae are so large they can be seen across millions of light years. In colliding galaxies, these regions stand out, glowing brighter than the rest. They are like cosmic lanterns announcing to the universe, something extraordinary is happening here. To us, they are also reminders that even in destruction, the universe creates beauty, painting the dark with light and color. And so the next time you see a photograph of glowing nebulae, remember, many of them may owe their existence to collisions. They are the flowers blooming after the storm, fragile, temporary, but unforgettable in their radiance. Giant star clusters, born in the wake of chaos. When gas clouds collapse during a collision, they don't always form single stars. Sometimes the collapse creates massive star clusters, groups of thousands, even millions of stars bound tightly together. These clusters glow brilliantly, shining like jewels embedded in the galaxies. They are the treasures left behind by chaos, born where gas was once torn apart. Young clusters are especially bright. Their stars are hot and massive, burning blue and white. For millions of years, they dominate the galaxy's glow, outshining older stars around them. Over time, they fade into globular clusters, dense, spherical groups that can survive for billions of years. In this way, collisions plant seeds of long-lasting light that orbit the new galaxy for ages to come. These clusters can be incredibly dense. If you lived on a planet inside one, the night sky would be filled with countless bright stars, far closer than those in our Milky Way. It would never be dark. The heavens would blaze with light. Collisions create these environments, turning quiet galaxies into fields of brilliant clusters alive with shining suns. The antennae galaxies, now in the midst of colliding, show this vividly. Telescopes reveal thousands of young clusters scattered across their shapes, glowing like beads of fire. These clusters are the direct children of collision, proof that mergers spark intense waves of creation. They are temporary spectacles, but their legacy can last longer than the galaxies themselves. So while galaxies lose their spiral arms in collisions, they gain something else: star clusters that shine for billions of years. It is as if the universe gives back more than it takes, scattering beauty across the sky to remind us of the creative side of cosmic chaos. The glow of infrared, firestorms after collisions. Colliding galaxies often glow in wavelengths we cannot see with our eyes. In particular, infrared light reveals the heat of dust and gas stirred by the merger. Astronomers call these galaxies infrared luminous galaxies. They shine like hidden firestorms, invisible to ordinary sight but blazing brightly in infrared cameras. Collisions awaken the galaxies and their glow tells the tale. The heat comes from starbursts. New stars form in great numbers, heating surrounding dust. The dust absorbs their light and re-radiates it in infrared. To us, it looks like a cosmic furnace glowing with warmth. These firestorms can make colliding galaxies among the brightest objects in the universe at certain wavelengths. From Earth, we cannot feel this heat, but instruments like the James Webb Space Telescope reveal it clearly. They show colliding galaxies wrapped in glowing cocoons of dust, hiding their newborn stars from visible light. In infrared, the truth emerges. The galaxies are burning with creation. It is a hidden language of the universe, one that speaks of energy, birth, and transformation. These infrared firestorms can last for hundreds of millions of years. Eventually, the starbursts fade, the dust settles, and the galaxy stabilizes. But during the collision, the glow is unmistakable. Astronomers look for these signatures to find galaxies mid-merger, reading the heat as easily as one might read smoke from a fire. And so when you imagine colliding galaxies, do not picture them only in visible light. Imagine them glowing with unseen fire, blazing in colors our eyes cannot detect. The universe shines in ways beyond our senses, and collisions are some of its brightest hidden flames. Why colliding galaxies look like cosmic butterflies? Some colliding galaxies, when photographed, take on delicate, symmetrical shapes. Long arcs of stars spread outward like wings. Bright centers glow like bodies. They look like butterflies suspended in space. This is not an illusion, but is the natural result of tidal forces pulling stars into mirrored streams. Beauty is written even into the mathematics of gravity. The butterfly galaxies, as astronomers sometimes call them, are striking examples of this. Their tidal tails stretch out in opposite directions, creating near-perfect symmetry. It is as though the galaxies have spread wings, ready to take flight into the universe. These shapes are temporary, but while they last, they are among the most breathtaking sights in the sky. The symmetry happens because both galaxies are pulling on each other equally. Stars are flung outward on both sides, tracing arcs that mirror one another. For millions of years, the galaxies glow in this butterfly form before slowly folding back into each other. It is a moment of balance between chaos and order, captured by telescopes like a photograph of a dancer mid-spin. But beyond the beauty lies a story. These shapes show us how predictable gravity can be. Even in collisions where everything seems chaotic, patterns emerge. The butterfly is not random. It is written in the equations of motion. What looks like delicate wings is actually the map of how stars respond to cosmic tides. So when astronomers share images of colliding galaxies that look like butterflies, they are not exaggerating. The universe really does paint such shapes. In the heart of chaos, it still finds elegance, reminding us that beauty often hides in places we least expect. As galaxies drift, collide, and merge, they remind us of something both humbling and comforting. Change is the heartbeat of the universe. The Milky Way and Andromeda are not exceptions. They are chapters waiting to be written. Their meeting will not be sudden or violent, but slow, patient, and breathtaking, reshaping the sky for whoever is here to see it. And as you close your eyes tonight, remember, even in the vast silence of space, beauty is always unfolding. The universe is still writing, and we are part of its endless story.